Metals and non-metals. In this chapter, we will learn about physical properties of metals, chemical properties of metals, and refining or purification of metals. Introduction. Element is a substance that can't be broken into simpler substances. Elements are classified into different categories: metals and non-metals. There are 118 elements present in the periodic table, 92 of which naturally occur. Metals. Metals are the elements that form positive ions by losing electrons. Thus, metals are known as electropositive elements. Metals are the elements that conduct heat and electricity, and are malleable and ductile. Group 1A consists of highly reactive metals, called alkali metals, while Group 2A elements are called alkaline earth elements. Between Group 2A and 3A, all are called transition metals. Examples are iron, aluminium, silver, copper, gold, platinum, lead, potassium, sodium, calcium, and magnesium, etc. Physical properties of metals: hard, and have high tensile strength. They are good conductors of heat and electricity. Except for lead and mercury, metals have the ability to withstand hammering, and can be made into thin sheets known as foils. Except for zinc, which is brittle. Metals are solids at room temperature. Exception: mercury is liquid at room temperature. Metals produce ringing sounds, so metals are called sonorous. The sound of metals is also known as metallic sound. This is the cause that metal wires are used in making musical instruments. Most of the metals are gray in color, but gold and copper are exceptions. Metallic oxides are basic in nature. Metals have shining surfaces. Non-metals. Non-metals are elements that do not conduct electricity, and are neither malleable nor ductile. Non-metals are those elements that do not exhibit the properties of metals. Examples: carbon, sulfur, phosphorus, silicon, hydrogen, oxygen, nitrogen, chlorine, bromine, neon, and argon, etc. Physical properties of non-metals occur as solids, liquids, and gases at room temperature. Bad conductors of heat and electricity. They do not have a shining surface. Except for iodine, generally soft. Except for diamond, a form of carbon, which is the hardest natural substance. They are not sonorous. Non-metals have a tendency to gain or share electrons with other atoms. They are electronegative in character. Non-metals have low melting and boiling points. Chemical properties of metals. Metals are very reactive. Metals tend to lose electrons easily and form sodium ions, sodium, lithium, potassium, etc. Metals react with oxygen and water or air to form metal oxide. Metals react with oxygen to form metal oxides. 2Cu plus O2 is 2CuO. When copper is heated, 4Al plus 3O2 is 2Al2O3. When aluminium is heated, reaction of metal with water, metal plus water, is metal oxide plus hydrogen. Metal oxide plus water is metal hydroxide. Reaction of metal with air, copper plus oxygen, is copper oxide. Aluminium plus oxygen is aluminium oxide. The reaction of non-metals with oxygen. Non-metals form respective oxides. When reacting with oxygen, non-metal plus oxygen is non-metallic oxide. When carbon reacts with oxygen, carbon dioxide is formed along with the production of heat. Non-metallic oxide. Non-metal oxides are acidic in nature. The answer of non-steel oxides turns blue litmus red. Carbon dioxide offers carbonic acid, while dissolved in water. The reaction of non-metallic with chlorine. Non-metallic offers respective chloride after they react with chlorine fuel. Non-metal plus chlorine is non-metallic chloride. Hydrogen offers hydrogen chloride, and phosphorus gives phosphorus trichloride while reacting with chlorine. The reaction of non-metals with hydrogen. Non-metals react with hydrogen to form covalent hydrides. Non-steel plus hydrogen is covalent hydride. Sulfur combines with hydrogen to shape a covalent hydride is referred to as hydrogen sulfide. The reaction of metal and non-metal. Many metals shape ionic bonds when they react with non-metals. Compounds so fashioned are known as ionic compounds. Ions, positive or bad charged atoms, are referred to as ions. Ions are formed because of the loss or gain of electrons. Atoms form ions attained with the aid of the electronic configuration of the nearest noble gas. Positive ion. A tremendous ion is formed due to the loss of electrons by means of an atom. Ionic bonds. Ionic bonds are shaped because of the transfer of electrons from the metal to non-steel. In this route, metals get a fine price due to the transfer of electrons, and non-steel gets a negative rate because of the popularity of electrons. In different phrases, the bond formed among tremendous and terrible ion is called ionic bond. Since a compound is electrically neutral, in an effort to form an ionic compound, bad and nice, both ions must be blended. Properties of ionic compound. Ionic compounds are stable. Ionic bond has an extra force of enchantment, due to which ions appeal to every different strongly. This makes ionic compounds solid. Ionic compounds are brittle. Ionic compounds have high melting and boiling points due to the fact pressure of enchantment among ions of ionic compounds is very strong. Ionic compounds typically dissolve in water. Ionic compounds are usually insoluble in natural solvents like kerosene, petrol, and so forth. Ionic compounds do not behavior power inside the strong nation. The answer of ionic compounds in water behavior power. This happens due to the fact ions gift in the answer of ionic compounds facilitate the passage of energy by means of transferring towards contrary electrodes. Source of metal. Metals occur in Earth's crust and in seawater, within the shape of Oz. Earth's crust is the main source of metal. Seawater includes many salts, along with sodium chloride, magnesium chloride, etc. Mineral. Minerals are clearly taking place substances that have a uniform composition. Ores. The minerals from which a metal can be profitably extracted are called ores. Metals discovered at the lowest of reactivity collection are least reactive when they're regularly observed in nature, in unfastened state, inclusive of gold, silver, copper, and so forth. Copper and silver also are observed inside the form of sulfide and oxide ores. Extraction of metals. Metals can be labeled into three components on the basis of their reactivity: most reactive, medium reactive, and least reactive. The three important steps concerned in the extraction of a metal from its ore are concentration or enrichment of ores, conversion of focused ore into crude steel, and refining of impure or crude metal. Concentration of ores, removal of impurities, together with soil, sand, stone, silicates, etc., from mines. The ore is referred to as a concentration of ores. Ores that can be mined regularly incorporate many impurities. These impurities are referred to as gangue. First of all, concentration is performed to do away with impurities from ores. The attention of ores is likewise called enrichment of ores. The process of attention depends upon the physical and chemical homes of ores. Gravity separation, electromagnetic separation, froth flotation method, and many others are some examples of the methods which might be applied for awareness of ores. Conversion of metals ores into oxides. It is easy to reap metals from their oxides. So, ores located in the shape of sulfide and carbonates are first converted to their oxides through the manner of roasting and calcination. Oxides of metals so acquired are transformed into metals by means of the process of discount. Thermite reaction. Ferric oxide, when heated with aluminium, is reduced to iron steel. In this reaction, a whole lot of warmth is produced. The thermite response is used in the welding of electric conductors, iron joints, and so forth, together with joints in railway tracks. This is likewise called thermite welding. Extraction of metals of high reactivity. Metals of excessive reactivity, along with sodium, calcium, magnesium, aluminium, and so on, are extracted from their ores by means of electrolytic reduction. These metals cannot be decreased the usage of carbon, due to the fact carbon is much less reactive than them. Electrolytic reduction. Electric current is surpassed through the molten state of metal ores. Metal, being definitely charged, is deposited over the cathode. For example, when an electric current is handed through a molten state, or answer of sodium chloride, sodium metallic receives deposited over the cathode. Refining or purification of metals. Metals extracted from various methods contain some impurities. Thus, they are required to be refined. Most of the metals are refined using electrolytic refining. Electrolytic refining. In the procedure of electrolytic refining, a lump of impure metallic and a thin strip of natural steel are dipped in the salt solution of metallic to be refined. When an electric-powered modern day is handed via the answer, natural metal is deposited over a thin strip of natural metallic from a lump of impure steel. In this, impure steel is used as an anode, and pure metallic is used as a cathode. Electrolytic refining of copper. A lump of impure copper metal and a thin strip of natural copper are dipped inside the answer of copper sulfate. An impure lump of metallic is hooked up with the advantageous pole, and a skinny strip of pure metal is attached with a poor pole. When electric modern day is passed via the answer, pure metal from anode actions towards the cathode and is deposited over it. Impurities present in metallic are settled close to the bottom of the anode within the answer. Settled impurities inside the answer are called anode mud. Corrosion. Most of the metals keep on reacting with the atmospheric air. This leads to the formation of a layer over the metal. In the long run, the underlying layer of metal keeps on getting lost due to conversion into oxides or sulfides or carbonate, etc. As a result, the metal gets eaten up. The process is called corrosion. Rusting of iron. Rusting of iron is the most common form of corrosion. When iron articles like the gate, grill, fencing, etc. come in contact with moisture present in the air, the upper layer of iron turns into iron oxide. Iron oxide is brown-red in color and is known as rust. The phenomenon is called rusting of iron. If rusting is not prevented in time, the whole iron article would turn into iron oxide. This is also known as corrosion of iron. Rusting of iron gives a huge loss every year. Prevention of rusting. For rusting, iron should be available in contact with oxygen and water. Rusting is avoided by way of stopping the reaction between atmospheric moisture and the iron article. This may be accomplished by means of painting, greasing, galvanization, electroplating, and alloying. Metals and non-metals. Metals. Metals commonly occur as tough, strong substances. Metals are malleable and ductile. Metals produce ringing sounds on putting, which is called their sonorous belongings. Metals are precise conductors of heat and strength. Non-metals. Non-metals normally occur in all three varieties of depend: stable, liquids, and gases. Non-metals are non-malleable and non-ductile. Non-metals do no longer display these sonorous assets. Non-metals are terrible conductors of warmth and power, with the exception of graphite, which is a great conductor of warmth and energy. Displacement reaction. When a more reactive metal reacts with the salt answer of much less reactive metal, the greater reactive metal displaces the much less reactive metallic from its solution. Metal A plus salt solution of metallic B is salt solution of metallic A plus metallic B. In the above equation, metal A is extra reactive than metallic B. For example, when aluminium metallic is dipped within the answer of copper sulfate, it forms aluminium sulfate and copper. Al plus CuSO4 is Al2SO4 3 plus Cu. in the above reaction. Aluminium is more reactive than copper. This is why it replaces copper from the solution of copper sulfate. From all these things, now we know about metals and non-metals.